separate component, the all folders become separate component, and then we have a nav bar, so which comes from the React navigation. So we have like 4 to 5 components because of this. And if you have, if you want to pass all these states across all these 4 to 5 components, it becomes tedious. Still, it's manageable, but if this grows by 2 more screens, it becomes really difficult. So I will show a graphical representation of this one. So the manage feed stack navigator, right? That is nothing but a React navigation component. So we named it as manage feed stack navigator. So this particular component is actually initialized from the native side with a set of initial props, maybe the selected cards and the all cards and then the folders. So here, once this receives this initial props, it actually has 2 root level components like manage feeds container and then the card selector. Basically, this screen and then this screen. So the manage feed stack navigator was sending all the states that was received from the native side to be maintaining all the state. It was stateful. It knows what is the current selected cards, what are the available cards, and what are the available folders. So when you tap on this plus button here, you see at the top we present the screen. So when you present the screen, we again pass props from that manage feeds controller to this card selector container. So here again, if you look at, we have 2 components. One is for all cards and another is for all folders. This is what you see: card list and then folder list. And then each list has its own item. So this particular thing is actually a separate component. Each item in that particular list. So what happened is when you tap on this particular plus button, user has selected that particular folder, right? This information has to be propagated back to the root component because the state is maintained there, right? So what happens is this gives a callback to the list view. Basically, from this item, you give it to the list, flat list or section list. And then from the section list, it actually goes to the container component. From the container component, it goes to the manage feeds. It is like you have 3-4 levels of callbacks. And if you closely note, this guy doesn't even care about who's a selected component. And even this guy, this guy also doesn't even care about who is a selected component. The only component that is interested in this flat list view item. So we just trying to gray out this particular selected card, right? So, but in this scenario, we are able to manage. Since we have only 3 screens, we are able to manage. But if you have a couple more screens or a couple of other components, it becomes really difficult to manage with just props and callbacks. So as I talked about this presentational component, container component, React also has some other ways of sharing state across multiple components. Like, have you heard about context APIs? Who knows about context APIs? Okay. So context API is actually one scenario that you can think of when you talk about context API is themes. Let's say you want to have an app-wide theme, okay, dark theme or white theme or whatever theme. So if you want to apply this particular style of colors and fonts and everything across all the components, if you don't use context API, then you have to pass props to all the components in your component tree, which becomes difficult, right? Because you have to, let's say, you just want to have a primary color and secondary color for your app. All the components right from the parent to leaf node should take that props. So that if you have an option in setting screen for user to toggle between themes, whenever user changes the theme, the entire component has to have the props, only then it can update. So in this case, you have to send the props from the root to all the way to leaf node. So context is something that is an alternate for this. Instead of you actually manually passing all these props from parent to all the way to the leaf node. So context API actually provides an option where you can set the properties to the context, and context actually enables these properties to be available in all the components. So these properties are implicitly available for all the components which are wrapped under context. So context has a component called provider. So if you wrap certain components under provider, all the components inside the provider will get that additional props for theme. That is the main idea. So the reason why I'm talking about this context is not something that is alternative to Redux. Okay, that is the reason I want to touch upon context. So context is something that is very useful when you want to have an app-wide data, app-wide access to single data, something like user session or something like theme that I talked about. So that is when it makes sense. So other thing is render props. Have you heard about render props? So render props is something from the parent component. You actually pass the child as a props. So something like a function. Render props is actually a function which returns an child component which can be customized by the parent component. So I'm not going into detail about it, but again, this is not the solution for Redux. So, or you can, as Redux suggests, sorry, as React suggests, you can maintain your own global event system where you will have your own global state, and then whenever the state is updated, you will throw notification to all the interested components. So this is something you go ahead and implement your own way of Redux or Flux architecture. So say the third thing is higher order components. So higher order component is something, but it takes a component and it applies some. It also takes a configuration, and then it gives you an enhanced component. So it is something like if you have worked in React, you might have used something like with router, with style or something. So what we generally do is when you write a component, you don't do a default export for that component. You instead do something like default export, and then you do with style of that component. So basically, on top of the component, you are trying to apply some other configuration. For example, in case of React, right? So whenever you type some URL in the browser, so based on the URL's path, your actual page changes, right? Your single page app or multi-page app, based on your URL, your page, whatever page you display changes. So for this, what we generally do is, for each component, you want to know what are the query parameters of the URL. So that URL is actually a global state for the entire React app. So to access this, we actually use something called with router. So when you do with router of that component, so this with router will actually pass all those URL related information to the React component, so that it becomes available as a props for you. So all it does is it takes a component and then configuration, and then it gives you a kind of enhanced component. And that's it. So in this scenario, you can also use it to share some state, but again, it is not a replacement for Redux.
One small request, sorry to interrupt. Can you please share the presentation?
Sure.
Just put it in.
Last minute. So I can continue, right? Or you want to
continue? But I'll just.
So who read out hooks? Hooks was introduced recently. It was like maybe 6 months ago. So it was a very interesting concept. So it is again a kind of alternative for Redux, but it's not a complete replacement. So hooks is something that enables your functional components to be stateful. So far, without hooks, functional component is completely stateless. It had only props. It never had state. But with hooks, you will be able to maintain the state by using the new APIs called useState and then use memo and all these things. Even the use reducer, all these things enables a functional component to become more stateful. So these are actually currently available features as part of React, which you might think as an alternative for Redux, but it's not completely a replacement for Redux. There are certain scenario use cases for each and every item in this list, but it is not a pure replacement for Redux. So we talked about all the state managements, right? So Facebook actually has something called Flux, which is actually a global event system architecture, which is implemented by Redux. And then there is an alternate for Redux or a competitor for Redux, which is called Mobix. So it is also widely used, but it's not as famous as Redux. So all these state management libraries, says, all it tries to do is it tries to simplify the state management for your React app. That is what it tries to do. So why we chose Redux among all these things? Flux is actually slightly complicated, so we didn't choose. Even a lot of open source projects, they don't go with Flux because it is slightly complicated. Redux is actually a simplified version of Flux. So that is one thing. And then other thing is it had only one store. If you go with Flux, it has multiple stores. But with Redux, you have only one store, and it is always an global state kind of thing. You'll always have a predictable state, or you'll always know what is the state of at any point in time. Second is actually a maintainable code. Since you have one single store, you have one single place to test everything, because your object state is always in one single place, so you can always easily test. Second is it also offers a time travel domain. Have you anyone done this timetable debugging? So it is actually an interesting part of Redux where you can move your app from current state to some state in the past time, and then you can again come back to the current time. Something like that. I will show the demo at the end. And then it also has something called Redux Dev Tools, and then a Chrome extension, which allows you to easily do all this time travel debugging and then look at all the outgoing actions and how your state is updated and all these stuff. So also, Redux is something that is widely used compared to any other state management libraries for React. So the reason why this is important is whenever there is a new update in React or React Native, this community actually takes care of updating that Redux to all the new APIs. For example, after React introduced hooks, Redux also come up with a hooks concept where it simplifies certain use cases of implementing Redux. So again, you'll deep dive into Redux from here on. So Redux is nothing but a predictable state container. Since it has only one store, at any point in time, you will be able to say what is the current state of your app. For any actions, you'll be able to say how your state will be updated. So Redux in itself, it's made up of all these five components. One is store, which is the heart of this Redux itself. Second is the reducer. Reducer is nothing but it says how to update the store. Third is dispatch. So basically, store has two properties, one property called two methods. One is get state. Second is dispatch. Third is subscribe. So store actually has these three methods or properties, wherein you can access the current state of the store using get state, or you can update the store using dispatch, or you can subscribe to the store for any changes using subscribe method. Okay. So whenever you dispatch some action, it goes to the reducer, and then reducer decides how to update the store. So I will go into detail on how to create all these things now. So if you are confused, you can wait for some time. I will explain in detail. So action object is nothing but the one that is passed to dispatch. So action object actually displays what is the type of action that you are trying to do and what is the payload. So basically the payload goes and updates the state. So action creators are nothing but helper functions which takes care of creating these action objects. So the component will simply talk to this action creators, and action creators will take care of dispatching the actual dispatch object or action object. So this is how the control flow looks. So the React, the red box here is nothing but the components that you have, the presentation component or the container component, whatever. The entire React actually sits at the bottom, the red box. What happens is whenever there's a user action on the component, like typing some text or tapping on a button or whatever, swiping or something, so it throws an action, it emits an action or something. So this action is sent to the reducer. So this dispatch particular action, that is how it is sent. So because as I mentioned, store has three properties: one is dispatch, one is subscribe event, and then get state. So when you want to send an action, you actually do it via dispatch. You dispatch an action. So when you dispatch an action to store actually simply sends it to the reducer, and then lets reducer to update the state. So reducer has a logic on how to update the state. So I'll go into detail of reducer. Reducer is actually a pure component where it doesn't take care of any what is it? You have side effects, right? It doesn't do any. It doesn't deal with any side effects. It's like whatever argument comes in, it simply updates the state based on that. So I will go into detail. So other way of looking at Redux is something like this. From the UI, throw an action, and that action actually updates the store. And then selectors is nothing but emitters or events or something that comes from the store, and whoever is interested can listen to that particular event and then update the. So slightly detailed version of the same thing. So here what we have is something called middleware. I will again go into detail later in this presentation. So again, the middleware actually gives you an option to customize the action before it reaches the reducer or store. So an action is dispatched from the component, but before that action reaches the store, you can actually go and play with this particular action. You can even decide to drop that action, or you can even decide to dispatch multiple actions from one single action. So without Redux, we saw before how it becomes difficult to actually share the state across components. And with Redux, so this is what happens. We have one single store, and one component actually updates the store, and whatever component that is interested in simply gets a notification or kind of listening event, and then it simply updates the UI based on that. So this kind of architecture actually avoids sending props to multiple components which is not interested in it. So previously we saw we are sending callbacks or props to all those intermediate components which are not even interested in it. So this kind of thing we don't deal with those kind of problems. So store, as I mentioned, it has three methods, which is dispatch and action. Subscribe, whoever wants to subscribe, you can do and subscribe. Like within the component in component build mount or dit mount, you can actually do and subscribe to a particular store.subscribe, and then you can actually get all the events. So third is get state. So wherever you are in the component hierarchy, you can actually simply say store.getState. It will give you the current state of your entire app. So how do you create a store? So you actually do an npm install on Redux, and once you are done with installing the Redux, you can simply go and say create store. So usually you do this in the root component of your app, whatever is the root component. You generally do this thing on the root component. So you do by importing the create store, and then the create store you pass the reducers. So reducer is something that you define. It can be a single reducer or it can be multiple reducers. Reducers are not, store is single always, but your reducers can be any number of things. For example, if you take something like an e-commerce app like Flipkart or something, uh, you can have two different reducers for products and then cart. So product reducer will just deal with the list of products, right, and product information. Like if a new product gets added, it will simply update your state. Cart is something is separate reducer which is going to take care of all the actions that is related to carts. Like if you add a product to cart, it will reflect there, and if you increase the count of that particular item in the cart, it will increase. So basically, you have two different reducers for controlling two different flows. But the store is still the same. The store is the one which is actually kind of holding both products and then the cart, but the reducer is different. So actually, if you have multiple reducer, you can combine the reducer and pause it. Second, since you have multiple reducers, or reducers actually take the initial state. This is an optional thing. If you want, you can pause the initial state here, or you can actually pause the initial state in the reducer itself. So I will say how to get so into detail later on how to set up the middleware and how to add the middleware to the store. So we talked about how to create a store. So next is how do you create actions. So action is nothing but simple method which dispatches an action object. So each action object should have a type associated with it, and then the payload. So the payload can be anything. It can be any key associated with the value, etc. So reducer actually takes this type and then this payload and decides how to update the store. It's very simple. So from the component, let's say you have some to-do list app or something. User types some text and then says add to do. So when you tap on add to do, it invokes method like this, like add to do something, and then inside that it simply dispatches or it simply returns an action object which says type as add to do, or here in this case it's like add session to a schedule, and then the payload as session information, which can be whatever user typed. So next we move on to reducer. So before I go on to actual full-blown reducer, I will tell you what reducer is. Reducer is actually a pure function. So when you say pure function, it is something like it doesn't depend on global state. So given certain input, it will always emit the same output. It will never change. So in this case, sum of numbers you give a and b, it will always return whatever a and b sum is. It will never change. But in case if you have something like a date parameter associated with it, let's say I add date.now here. So the date.now is going to change at any point in time. Whenever you run, it's going to change based on that. So the date.now is actually a global state. So if you depend on that in this method, it is not a pure function. So because whatever input you give, the output will differ based on your time. So the important thing to note is reducer should always be a pure function. It should never be dependent on any global thing, or it should not even care about side effects. So again, to sum up, it should not make any API call like fetch or any database call or anything like that. It should not mutate the data. So this is the important thing. So whenever you, so what I told before is reducer takes care of updating the state, right? But here I'm saying it should not mutate the data. Then what it means? So it's like you have a current state, you should not go and simply update that state. You should always create a new instance of that state and then update that one. So the reason why we are creating a new instance of the state is because of React. So React's reconciler logic works based on this. It doesn't work based on a shallow checking. It always doesn't. So it works based on shallow checking. It doesn't work based on deep checking. So, for example, if you modify a state, you should always create a new object for that state. If you simply mutate that state, it will not end up in rendering your component again, right? So that's why you should not mutate the data. You should always create a new instance of that particular state and then return it from the reducer. So this is optional. You should not do a console log on screen, and you should not refer to data now. Again, you should not do any async await or any kind of promise callbacks inside the reducer. It should be a very simple function where it takes a state and then the action and simply gives you a new state. That's it. So this is how a full-blown or a simple reducer looks like. So it takes the initial state. So the state where you have initial state, this is where you actually set up the initial state for this reducer. It can be an empty in case of products, or in case of cards, it can be an empty thing. And then it takes an action. So action, as we saw before, when you dispatch something, you actually specify this type and then the payload. So this is what actually comes in here. And then you actually read the type, actions type, and then you know what is the structure of that action. So because you know this is the type, you know what is the structure of the payload. So using that payload structure, you actually update the state. So this is how we actually construct a new state instead of mutating it. So we use a spread operator and then we create a new instance of that state and then we simply update the properties that we want. So if there is some other action type that we don't care about, we simply return the current state. So as I said, we can have multiple reducers. There may be scenarios where certain reducer doesn't care about certain type of actions. Right? In that case, we simply return whatever the current state it is. So Redux is something not specific to React again. You can use it across Angular or jQuery or even vanilla JavaScript. So far, whatever we discussed is actually a pure Redux. There is nothing related to React if you closely listen. So for using this Redux inside React, we have another module called React Redux. Again, you need to do an npm install for this. So once you do, it actually provides few capabilities. One is it enables you to access store at anywhere in your component hierarchy. So it actually uses something. It is something similar to the context API, but it provides something called provider. So you actually wrap your root component with provider, and then you set the store to this provider, and then it takes care of giving me a store as accessible item inside any component. And then it gives one more thing for higher order component, a method called connect. So basically what you do is your component will still work in terms of states and props. Your mapping for Redux and Redux related things like store and then reducer are happening on higher order component. So as I said before, higher order component is nothing but it takes a component and then it takes a configuration and then it gives an enhanced component, right? So it is something similar to this. This connect method actually takes a component. So let's say in case of e-commerce app, it can be a product list. It takes a product list component and then it also takes some information from the store and then it makes sure your store state and then component state are in sync. And then whenever you dispatch something from the component, it is going to the store. Something basically it gives you capability for state in your Redux to be accessed inside the component, and then also to update the state from your component. So I will go into detail on how this is being done. So if you look, the store and React part is actually covered by React Redux by providing all the components access to the store. So we'll also talk about how you map Redux state to props and also stores dispatch to actions inside the component. So if you want to create a store, as we talked before, this is how we create. So I'm not passing initial props here. I'm just creating a root reducer, which is actually a combination of multiple reducers. In real world, you don't actually deal with single reducer. You have multiple reducers, and then you have a method called combine reducers from Redux, which actually takes care of combining multiple reducer in one single reducer, and then you can pass that one single reducer to the store. And then Thunk, you might have heard about Thunk as well. Has anyone worked with Thunk? So Tank is something that allows you to do an async activity within your action creators. So we'll talk about middlewares later. So this is actually how you create a store. You simply import create store from your Redux, and then you pause reducer, and then if needed you can pause middleware. You can leave it as empty. So we talked about provider, right? How a provider enables all the components in the React to access the store. So this is how it is. So provider is again coming from react-redux, which is specific to our React. It's actually a convenience thing which provides all what do you say, all the properties that is needed to easily work with React components with Redux. So here, if you see for the provider, we simply set the store. This actually enables all the components inside this particular tree with access to the store. That's it. So in this scenario, we are actually talking about React Native, right? So I thought of taking this example where we talk to a native module asynchronously. So here, the app that we actually recently worked on, it had something called get list of actionable apps. So it is like Jira apps or a lot of actionable apps that we have. So this app information is actually residing inside our native code. Okay, and then we have a native module which actually takes care of returning a list of actionable apps. So here, if you see, this is actually an actions creator function which actually dispatches something instead of returning in something like this. Instead of returning something like action type and the payload, it is actually doing something different. You notice closely, it is actually doing a dispatch. It is not returning any object here. And then it is actually invoking a method get action apps from native. It is actually returning a promise, and then based on the promise, we are actually dispatching some actions. Correct. So instead of directly dispatching an action, we are doing some async activity, and then based on that async activity's result, we are dispatching with that. Correct? So this get action apps from native is actually a native module thing. I will show this one. Yeah. So this is actually a native module. If you see, we are importing native modules from React Native, and then this action module is something, action app module is something that is defined and declared inside our native code, in the iOS or Android. So when you invoke this method, this actually invokes an native method, Objective-C method or Java method, and then it awaits on that. So whatever communication that you do for native modules is always asynchronous. It is not synchronous. So you have to await on this, and then when the promise is resolved, you actually return this data. So when you return this data, so you either go into the if section or the else section, and then you based on that you actually do a dispatch. So you got what's going on here, right? So basically, instead of directly dispatching it, we are calling on async function, and then based on this async function's result, however it resolves, we dispatching based on that. So so far we saw how to create store, how to provide that store through the rest of the React component, and then we saw how to dispatch an async function instead of directly dispatching an object. So now we are going to see how to make a component to use all these store and dispatch things. So let's assume I have an component like action screen, and this is actually higher order component which takes this component and then it maps the props to state and then props to dispatch. So what happens here is if you see the first method map state to props. So what it does is whatever property you want for that component, let's say for this action screen, whatever property you want, you simply declare those and then map it to corresponding state. For example, here I want an actions data array, and then I map it to corresponding Redux store state. So here you can actually specify whatever state that you are interested in. If you are interested in the entire state, you can simply give state instead of giving state.actionapps.data. You can simply give state. So second is for dispatching access to the store. So this is basically for updating the store. The first one is actually for getting the updates from the store. The second one, what we do is again whatever dispatch methods that you want, you simply declare it. Here in this case, it's like get action apps, and then you map it to corresponding actions that you created. So this is what we created before, right? So we simply map these two. So there is a convenience again here. You can simply use bind action, which will take care of adding all those arrow functions there. So basically what is going on here is first map state to props. It actually takes care of mapping your props to a state in a Redux store. Whenever store changes, this actually takes care of updating your component. So second is how you map your actions that is happening in your component back to your store in the Redux. Basically how you dispatch it to store. So here what we do is we whatever actions that we want, we simply declare it here and then we map it to corresponding dispatch operation. That's it. So what we at the end, if you see, we actually do an export default connect. Instead of doing export default action screen, we actually do an export default on connect. So this returns a higher order component instead of actually using the action screen. So when you use a higher order component, it actually comes with all this mapping on its own. So this we already saw. This is the native module that we use to fetch information from the iOS or Android. So yeah. So this is actually the reducer for this particular example that I showed. So here what happens is it takes the initial state. Initial state is nothing but an empty thing. So action here is that is thrown from here. Okay. So I invoke this method to get list of all actions from actionable apps from the native. So let's say in this case the problem is resolved successfully, and then here I'm trying to dispatch get action apps, and then with the payload. The payload here will have the all available actionable apps. So here if you go, if action type is one of get action apps, then what we do, we go and spread the current state. We are trying to create a new instance of that state, and then we also attach the new data that is available. So whatever data that native module returns from here, it should be updated in the state now. Correct? And then we simply return that state. That's it. So once the state is updated, so because of the mapping where you do map state to props, your component will get an event where it has to be updated. So basically, this actually takes care of subscribing, which means whenever you update the store, your component gets re-rendered. So this is actually a very simplistic implementation of Redux. The store, action creators, and then the reducer, and then the higher order component, which actually takes care of mapping the state and dispatch to whatever the component that you are interested in. So now we will move on to the middleware. So this is slightly advanced concept, but it is very simple. So all you need to do is declare something like this. So the function signature looks like this. The prototype looks like this. Function prototype. It takes a dispatch and gets state, and then it returns a function with next, and then it returns a function with action. So what we do is when you declare a method like this, and then export default constant is action logger, you can actually attach it to. So I'll show the code, actual code. So, but this is how the syntax for declaring an Redux middleware looks like. Okay, once you are done with declaring this one, you can actually go back, and when you create a store, you should apply that middleware. So basically, in this case, instead of thunk, I will be applying the logger middleware or whatever I declared. The action logger will be the one that will be passed as in the middleware, apply middleware. So again, we have two famous middlewares. One is thunk, which is actually used for dispatching async things, and Saga is also similar to thunk, but it is like in certain scenarios it is slightly better when you have nested async calls. Like you make one API call and then followed by another API call, followed by another API call. Thunk kind of doesn't look good. It makes you create something like very nested hierarchy. But Saga is something, it makes use of JavaScript generator function, so it kind of looks better. So people sometimes prefer Saga, but most people prefer thunk. So again, you can create a custom middleware, something like this. So I will explain the use case why you need a custom middleware. So let's say something like you are trying to implement Google Analytics in your app, right? So Google Analytics, what it does, what kind of analytics, not just Google, whatever analytics you want to collect from your app. So basically it tracks user actions, right? Whatever user taps on the screen, you try to send it as an action to your backend server. So here actually these kind of custom middleware helps. When you put a middleware something like this, it gets invoked for whatever action that is dispatched from your component. So whatever component dispatches an action, your middleware gets invoked. So in this middleware, it's one single point where you can actually send analytics event, or you can do a console log or whatever.
Do you mean we can catch the events?
Yeah. So middleware is something it actually sits in between your dispatching and then the store. So whatever middleware you apply to the store, it gets invoked before that particular dispatch goes to the store.
So we don't need analytics like analytics. What it do, it catches the events like Flurry or some Google Analytics.
Yes.
So it catches the events. How many buttons the users are using, which feature. So in this type we can use this one for logging the events.
Yes. This can be an alternative.
Okay.
It cannot be a full-blown thing of whatever they actually hook into all these events and then they do it, I think. But for a simple kind of analytics, this is better actually. So I will actually show a demo on how this can be done. So before that, again, using this middleware, you can do certain really cool things. One is, let's say a component dispatches some actions. So the middleware can catch this action and then it can dispatch multiple actions to it. Instead of one single action, it can actually dispatch multiple things. Or let's say something like, I'm going to demo a to-do app now. I have a plus button there. Okay. So when I tap on this plus button multiple times, it keeps on adding empty to-dos all of a sudden. So what I wanted to do is, the plus button should be working only after every second or every 2 seconds or something. Okay. So what happens when I tap on a plus button is dispatches an action saying add to do. So using middleware, what I did is I simply added a set timeout kind of thing inside the middleware where it blocks all the actions for 1 second and then it only dispatches after every 1 second. So I will show a demo on how it works. So other use case can be something like, let's say if you want to do some fetch operations, let's say fetch books or fetch authors or something. So typically what you do is you write something like this here. This is actually action creator function. So where you here actually I'm doing a native module dispatch. Instead you will use a fetch call. So here when you do a fetch call, you actually compose all the requests, right? What is the path? What is the method? What is the authentication things? All these things. So you actually consider the full-blown fetch request and make a fetch request here itself. So instead of that, what you can do is you can actually dispatch an object with some payload information like get authors or slash authors or something. In case of books, you can simply say slash books or something. Yeah, middleware that is specific to API can catch this particular type of dispatch, and then it can have one single implementation of fetch, and then can actually perform fetch based on the payload that is this method is sending. So instead of implementing fetch in every single actions, you implement fetch in one single middleware, and then you simply dispatch payloads to that middleware. That's it. So I will again demo this for it to be more clear. So there are a lot of use cases of this middleware. I would strongly encourage you to try it out. It's very simple. I will share the sample project as well. There are a lot of things that you can make it simple using this dispatch. So you can even decide whether that particular dispatch should happen or not. Middleware can say this is not the right time to dispatch this event. It can simply drop that event. So your component will simply emit the event, or whatever user taps on it, it will simply emit that particular action. But your middleware can be more intelligent and simply say this cannot happen. Something like that. So I will switch on to the demo. So I will show the code second. I will first run through the demo first. So this is a very simple to-do app. So let's say I had to do something like this. So at the left, right, you saw something in the black. So that is actually an Redux dev tool. It is a debugger tool. Whatever action you perform, it simply lists there. I will try to zoom in a little bit. So it is called. It's difficult to zoom. So I will zoom it after adding few to-do items. So I'm adding one more to-do. You will see a corresponding action getting displayed there. Whatever action that is getting dispatched from that component is getting displayed there. I will add one more, and then I will, let's say, mark 2 as completed. So you see a different action getting dispatched there. And then let's add one more, and then let's delete third one. So you'll see corresponding action getting displayed. So the cool thing about this particular Redux dev tool is you can actually time travel. There is a play button here. I'm going to play this. It's going to play all the action that I performed right from launching the tab. So this is how it was initially. I added 1, 2, 3, and then I marked 2 as complete, and then I added 4. I deleted. So it actually plays all the actions that happened so far. You can even jump manually to particular action, particular state by doing a jump, and then you can even jump back. So you can actually do a lot of things with this Redux dev tools. This is just a simple demo. So I'll jump onto the middleware thing.
It's a Chrome app. Comes in Chrome.
It comes in Chrome as well. So I'm actually using React Native debugger, but it is available in Chrome as well. It's an extension that you need to install. Redux dev tools. So the source code is very simple.
There's another question from online. So
Okay.
can we add catch block instead of if else
Yes, yes, that is something we actually didn't do.
in actions? Okay.
Yeah, it should be an. We didn't handle that catch there.
Okay.
Whenever there's an error, it will not work. Ideally, we should be doing that.
Okay. Sure.
So I'll start with how we create store here. I hope it's visible, right? So I am actually commenting out the current middleware. I will enable it and then I will show how it works. So here, if you see, we have reducers. So let's see first how we create the store. We actually create a store using reducer and then the enhancer. So this is something that we have to add to enable the Redux dev tools. This is not needed for protection. This is just for debugging. You can remove it. So all we need is only this enhancer with whatever middleware that you want to apply. Right now, it is not applying any middleware. It is simply passing an empty enhancer to it. So, but primary thing that is required is reducer. So let's see how the reducer looks for us. Sorry about that highlighting. So what happens here is we have different types of actions. I will show the actions first. So these are the different actions for the to-do app, right? You can either add to-do, remove to-do, or you can mark a to-do as done, or you can mark a to-do as undone. So these are the possible actions for our to-do app. So I declare all these actions now. I also write a corresponding action creators for it. So when I say action creator, is just a simple function which will dispatch an action object. Okay. So here, if you see, there is a function for each corresponding action that I declared before. For all these actions, we have a corresponding action creator functions, which actually dispatches the particular action object. If you see, type is something that is definitely needed. On top of it, you can pass any information that you want. It can be any key value pass. Nobody cares, as long as reducer is able to identify what the payload is. So if you see, for add function creator, I simply say add to do action type, and then I simply. So the meta throttle I will come back later. So that is actually one middleware thing that I added. So I will come back and explain what it is. So, but it is simple as other things. For remove to do, we simply say what is the section that we want to remove and what is the item. That is not needed actually, but we are just pausing it. So for example, if you want to mark an to do as done, we simply pass the index to it. So if you go to reducer, this is how it looks. For each actionable type, action types, we have a corresponding logic to update the state. In case of added, we simply say push. We create a new array and then we simply push it. That's it. In case of remove, again we do a slice and then remove it and then we create a new state and then return it. In case of undone, it's the same thing. We create a new state and then we simply update that state and then return it. Any questions on this reducer? Clear for you?
One thing, you use switch case, right?
Yeah.
So can we write some other way, like it's like some kind of mapping we can do? Or?
Yeah, you can do. You can even do if else, or you can do any kind of mapping. But switch is something that's commonly used. But yeah, you can do anything. All you need to do is update your state properly. That's it, based on the action time. And it should not be, as I discussed before, it should not be talking to any local state. but it should not be doing any side effect logic here. So based on whatever arguments that you take, like state and the action, you simply update the state using the action. It can be done using switch or it can be using any kind of mapping.
Can you give some example? Like, we don't want to use switch or if statement. Can we do like some, it's like we pass a key, like our key is like our action type, and it automatically invoke our reducer. Then it's like a mapping key with a action type.
Mhm.
It's mapped to a reducer.
So the concept here is you attach reducers to the store, right?
Yeah.
So whenever you dispatch something on the store invokes all the reducers.
Okay.
So it doesn't care about what kind of action type that particular reducer is interested in. It simply sends that action object to all the reducers. So it's up to the reducer to respond to that particular action or return the same state. So here, if you want to have a dynamic behavior within the reducer instead of adding a switch case, yeah, we can definitely do it. But it's up to us to write that logic to dynamically have that dispatching. So now we saw how to create a store and how to create actions and then the reducer thing. So now we see how to connect to this components. So this is the actual to-do list component. So if you see, this doesn't know anything about how the data comes. It simply has a props and it works purely based on the props. So whenever you do add, it simply says props.add to do, and when you do a delete, it simply says props.remove to do, and then it says done to do something. So all these methods, if you remember, it was declared inside our action. But how it became available here is something I have to tell. But any guess how it became available here? So all these props are true. Yeah, correct. So basically, this higher order component makes sure all these properties are available for this particular component. So and then it has its own render logic to render all the to-do list items with selected state and all these things. So let's move on to this container where we map actually. So here, if you see, first we try to map the state to the props. So this to do will be the props in your component, higher order component is operating on. And then this completed task is, we actually segregated two arrays. One is list of all to dos, and then second is list of all completed to dos. So, ideally, you can have one single array, but we have two arrays. Second is where we map dispatch actions to corresponding prop functions. Okay, so here we have add to do, which is actually mapped to the corresponding actions to do. So there's a simple way of writing it instead of we wanted to show how actually this works. That's why we wrote it. But there is some binding function which you can use it to simply make a binding. So all that happens here is we declare all the prop functions and then we map it to corresponding actions that we declared. And then we also use dispatch so that it gets dispatched to the store. So this connect line at the end, which actually makes sure your component is having all these props. Basically, it takes all these map state to props and then map dispatch to props, and then it applies this configuration on to your component. In this case, it's to-do list. So once this is done, you should be able to do all this time travel and everything. Okay. So now let's deep dive into what the middleware is and how to create a simple middleware and how to apply this middleware. So you see, there is something called middleware folder here, and I have a very simple middleware that is declared. So this is the one that I showed in the slide. So where we simply have this function prototype right here, and then all it does is does a console log, doesn't do anything. So once you're done, once the middleware is done with its own operation, it should actually give a chance to next middleware in the hierarchy. If you don't do this next action dispatch, your dispatch will never reach the store. If you remove this line, it's like your actions will never reach the store. So this middleware is very simple. It does a console log. It doesn't do anything. So I export this middleware, and then if you go to the store, and let's say we enable this one for me. So this middleware should be available now. So I simply go and do and reload here. So now whatever actions that I add, it should have a corresponding console log for. So basically, it's like an kind of a hook that you get to whatever action that is dispatched from your React components. It's up to you to add logic there to decide what needs to be done. So in this case, it is just doing a console log. The cases like analytics can also be an option where you can send analytics to your server. Second is the one that I talked about, this throttle, where so currently if you look at it, let's say I type some content in the to-do field, and then I accidentally type this twice, tap this twice. Okay, it ends up adding one more empty to do. So I don't want to give this kind of experience to users. So what I do is I add a slight delay to this plus button to make sure even if you accidentally type, you don't end up inserting an empty to do. So for this, I had one more middleware which is called throttle. So all it does is it actually looks for any action which has a meta information, which has a throttle inside it. So if an action has a meta, and then if an action has a meta and then throttle, it tries to act upon it. Otherwise, it simply returns. If you see, this is what it does. So this particular middleware is interested in certain kind of payload. If the payload is there, it will act on it. Otherwise, it will simply ignore. So here in this case, it looks at the meta, and if there is a throttle field, and then it goes and does a throttle for it. It actually maintains a mapping. If there is an already an action which is getting throttled, it will simply ignore. So
where do you pass the meta information from?
Yeah, I'll show it. So if you look at the actions, right? So I asked you to ignore before. This is where we are actually passing it. You can actually send any information here. So these are actually information that are needed for your middlewares. You can pass anything that you want, and middlewares can just simply look for this particular thing and then act upon it or simply ignore it. So in this case, actually, our middleware looks at the meta and then if throttle, only then it will act on it. It will not act on any other actions like remove to do or anything. It will not act on those things. So now for this thing, we need to enable in the store. It's already enabled. So now let's go back to this. Let's reload this. So now I'm going to tap this twice continuously, but I don't want to end up in adding more than one. So like, it doesn't add more than one. So basically, it kind of dispatches the particular action only after a certain time. Whatever action comes in between, it is simply ignored. Yeah, that is pretty much with the demo. I have one last thing to say. Sometimes if you go with Redux for every single thing, you may face some problems. So also there is another case where you should kind of look for some points where you should go for Redux. So these are the areas where you should actually go for Redux. If you are facing problems with too many callbacks, as we discussed before, that is one scenario where you can think of Redux instead of going with too many callbacks in the intermediate components. Second is if you are maintaining duplicate components. I again talked about this selected chord state, right, being maintained in multiple. That is one solution, but it will not work because if you maintain duplicate states in different components, the state can be in a different states actually. So if you are maintaining duplicate states, then definitely it means you should look for Redux. And if you are having problems, basically this comes as part of the second state. If you are maintaining duplicate states, then it becomes difficult to maintain a proper state across your app.
For example?
So for example, let's go back to this one. So in this case, I told you like we have a set of selected chords, and that particular state is actually needed in all these three screens, right? So if you maintain these states across all these three screens, you may end up in inconsistencies. For example, the third screen has a control to say what are the chords that are selected. You can deselect and unselect it. So if you do a mutation with this local state, your first screen and second screen will be out of sync, right? So this is where the problem comes. When you have duplicate states, then you should definitely look for Redux. So other thing is if you are again the same thing. If you are passing too many props to the hierarchy of component, again you should look for Redux. And again the basic thing, if you are having state that is shared across components that doesn't have a common parent, that means again you should look for Redux. So basically what we internally experienced this. If you have components more than 10 or 20, it's definitely worth to look at Redux because you will end up with all these problems if you don't have Redux or any other proper state management solution. Yeah, that is pretty much from my side. If you have any questions, you can ask me.
Action dispatcher is always serial, or assume you have more than one.
That is always serial. It is processor in
So
serial.
the same model is maintained based on which component is dispatching the action.
It's not based on the structure of the component. It's based on how it is dispatched. That's it. Whoever
Which
gets the
dispatch
priority.
first, that will go.
Yes.
Does it follow the event flow? Let's say that there's a set amount as asynchronous.
Yes, yes, it follows the event flow.
One more question. Can you go to that screenshots yourself?
App screens.
App screenshots. Yeah, it's not a Redux question. It's like you. This is the folder hierarchy you are displaying.
Yeah.
So that's let's say for that you are using a React Native module or you are using some
So this the second to final screen, right?
final screen.
That is purely React Native. The first screen is around the native thing.
So those are how you get those folder structures.
So the native actually constructs a JSON object and then it passes it to React Native.
Okay, okay. First thing you said you send some payload.
Yeah.
From there you get the structures.
Yeah. So when you from the native side, when you launch any React Native screen, you can send some props, initial props.
So you are using some icons to indicate that folder. This is a folder or not.
Yeah, we have a model which represents this is a folder and this is a card and all. So the model we send from the native is actually having this.
So from the beginning you are sending all those information.
Yeah.
Using those information you are just printing.
Yeah. So basically we send three sets of information. One is currently selected cards, and then list of all cards, and then list of all folders as a JSON. Any other questions?
You did mention about the Redux with hooks, right?
Yes.
Any examples on that?
So, so there is something called use selector that recently got introduced. I think still it is in beta. I think it's not released yet. Using this use selector, you can actually instead of declaring this higher order component, right? You can actually use this use selector to actually map all the states in the functional components. So this is only for functional components. Right now, if you want to have functional component to be in Redux other thing, so this is actually easiest way of doing it. So inside the functional component, you can simply say use selector, and then you can map your states and actions based on it. So basically, it's a replacement for connect. That's it. Thank you for being a nice audience. Thank you. Special thanks to Vivek.